So I guess first of all, thanks for having me on board. And it's obviously a time zone difference, but I'm glad to be here regardless. So yeah, looking forward to sharing some tips and tricks. So I guess I was approached originally just to talk about this topic based on a YouTube video. I originally started repackaging the video just as it was, and then I decided instead I'd use some sample models I've been working on just to make it a bit more interesting. I'll just share my screen. So hopefully this works. So hopefully my screen's coming through. You're seeing two models?
Yeah, we're seeing that. Thanks.
So we'll be using these two models during the presentation. I'm doing a live demo because I like to live dangerously. I'll just get the presentation up. So I'm obtaining meaningful quantities from Revit models, sort of focusing on 5D a little bit, but more so just getting quantities and scheduling is sort of the focus because Revit is a highly capable program of generating quantities. It's just that a lot of people don't know how, or they don't know some tips and tricks that make it a bit easier. So I guess for those that aren't aware, I'm from Sydney in Australia. So I sort of see it like this, I guess. I'm on the other side of the world. And yeah, it's a pretty beastly time difference. So it's about 4:30 in the morning where I am now. So if I'm a little bit sluggish, you'll have to excuse me. It's probably just this time. I'm just going to rearrange my screen a little bit. I've got all the Zoom controls in the way. Just give me a sec. There we go. But this is me. So I guess they've introduced me as Aussie BIM Guru, but my name is Gavin Crump. I've got an architectural background and I'm based in Sydney, but I used to live in a city called Adelaide and grew up there. But I've been in Australia my whole life. I'd love to travel to the UK one day. Lots of things I need to see there. I've been in AEC for about 10 years now. So I've got to a point where I'm pretty confident with not only the tools, but also the workflows and how we actually deliver projects. And that's sort of become a real focus for me in what I do with my business, helping other businesses actually deliver BIM in a meaningful way. I've worked with BIM management for about 5 years, but I've moved on into a consultant capacity now. And I specialize typically in Revit and Dynamo, but I do branch into, say, Rhino and Grasshopper and some other alternative platforms here and there. So my work on my business is BIM Guru. I launched this in March, sort of launched it in February, but it was a pretty soft launch because COVID came and hit pretty much as soon as I was going to launch. So it was a bit of a funny spanner in the works. I just work on my own at the moment, but I do help quite a few clients and I make a lot of articles too. So feel free to follow me on LinkedIn if you're trying to keep in the know of what I'm up to. And I do all sorts of things in my business. So these are like the 5 core services I offer, but probably the one that relates most to what I'll be talking about is BIM strategy. I've actually helped a few clients set up full cost takeoff models from their Revit systems from the ground up, and templating is critical to this. If the template doesn't work, then the cost takeoff doesn't work because the data structure isn't predictable. And this will sort of be a recurring theme throughout my presentation. I also produce Revit content and sell it as well. I know a lot of consultants do as well, but I offer it at a very cheap price because I do think the industry does need affordable but good quality Revit content. And I do want to see the industry just improve in Revit. And I think this is one of the keys to it. So if you are looking for cheap content, feel free to check out my website. And I do offer discounts if you're a student as well. In future, I'm going to be making some online courses. I've been producing some sample projects. You might recognize this one on the right. Which looks a little bit like the advanced Autodesk sample project, but I've sort of given it some steroids and built it using my own template. And it's hopefully going to give people a better training platform to learn Revit and learn BIM. I'm going to focus more on things like model management rather than just the basics. So unlike a lot of courses where you might just make a wall and put a door in it, I'm going to give like a full proper BIM model, and we're going to actually learn Revit properly. So hopefully in the next couple of months, you'll see some action there. But you probably most of you probably know me or have met me through my YouTube, Aussie BIM Guru, which I made last March. And I've pretty much just been producing tutorial videos, so Dynamo, Revit typically, usually about 30 minutes long. And I just try to teach people how to build workflows that they can take back to their companies and use. And I actually know a couple of faces here that I've actually given workflows to and helped them sort of solve some problems in their companies. So it's great to sort of meet those people in the UK. And I also do podcasts here and there. So if any of you podcast, let me know. Happy to come on board. So almost 200 videos. I'm on break at the moment from YouTube, but I will be back progressively. So if anyone here is sort of worried that I'm not coming back to YouTube, don't worry, I'm coming back. Anyway, to the point. So I was approached by Matthew because I made a video on 5D BIM and cost takeoff where I showed 4 different methods of generating schedules from Revit. It's about a 40-minute long video, so I did have to really package it down. So I will skip a few things here and there, but I'm really going to be focusing on a few things. So I'm just going to start by talking about the dimensions of BIM very briefly, because I think most of us know the dimensions of BIM, but I just want to give the context to what I'm talking about. I want to just briefly talk about how Revit should be used for 5D, in my opinion, because there's so many programs out there now that do very different things. And Revit's just one of them. So I think that to make Revit do everything is probably not the right approach. Rather, Revit can enable a better workflow. And then some key considerations for how you can model or how you should model to enable a 5D ecosystem. And then I'll look at some typical methods you can use to generate schedules and quantities from Revit. You'll have to excuse, I'll have a few jokes and memes in here. I've got an Australian sense of humor, so hopefully it doesn't offend anyone, especially Autodesk. But anyway, these are, I guess, like the basic dimensions of BIM. I think I got them right. It seems like there's 2 new dimensions every week when I check, so there's probably another few dimensions I'm missing there. But I guess I'm really focusing on, sort of 4D, 5D, the combination of time, quantification, and cost and estimation. More so 5D, I guess. But we're really focusing on cost planning enabled by quantity takeoff. So how much are we going to cost, and how many things are generating this cost? So I'll be focusing mostly on quantity takeoff. But I guess, like I said, Revit's really only just a part of a bigger picture in enabling a cost takeoff system. You can generate an entire cost takeoff system entirely inside Revit, but you are sort of at the mercy of how Revit will measure and tell you figures, which sometimes can't always do what you need. As well as this, I think that storing all the cost data inside Revit isn't always the best strategy. Now that we're seeing that a lot of BIM is moving onto the web, or we're getting access to databases now, it's much easier to actually control data in many places at once, and you can store a lot of data outside the model now. Even programs like Derofus, if anyone's seen that one before, I've used that before to essentially store the entire specification outside the Revit model, and all you need is one code on an object that points to the right place. And as a result, you really only care about modeling the right number or the right count of things, and the rest is really handled in the database. As well as this, I guess there's programs like Dynamo and Power BI, which sort of allow us to mine our data and display our data in much more meaningful ways, usually outside Revit as well. So I find that this is sort of enabling us to not necessarily do everything inside the model. So I sort of work a little bit like this these days. I tend to form like a code or a handle, and you'll see these sort of codes all throughout my models that I'm showing you today. I use a universal convention, and I still also apply uni-class coding and some other systems like IFC export as and type parameters. I do have my own proprietary system that I also give my clients to work with as well. And all my content I sell follows the system as well. And essentially it's really just a handle that points to somewhere else. So I guess with quantity takeoff, I'm always trying to encourage people to rely on computers wherever possible and try not to use manual measurement of drawings. I mean, this should be obvious, but I still work with a lot of QSs that are still measuring off drawings because it works for them. But the question is, does it work for the team? That's more what I usually have to reinforce to them. And I guess that ultimately the biggest point that I'll be running throughout this entire presentation is that your model has to be built to enable the cost model. If your model is not of a good quality or the data systems aren't set up properly, you're going to have a bad time. It's not going to work. It does take investment up front. Some of my biggest clients that I've done cost modeling for, we've had to invest a serious amount of time at the front end of the projects until they see the results on the back end. And I guess, as everyone always says, rubbish in, rubbish out, or a lot of other more flowery words that people use, but it's the same principle with data. If you put rubbish into your model, you're not going to get anything good out of it. And that seems to be the biggest misconception with I guess, cost takeoff, that the model is meant to generate the data for us, whereas really the model's just an environment that we can model in to support something that we design as a system. So I guess the 4 principles that I follow, I'm just going to summarize in 4 slides. This is sort of them summarized, but first of all, I guess, we have to model things properly. We're in a 3D BIM modeling platform, but I still see these sort of things where we sort of work with a half in, half out approach when it comes to committing to a BIM model. It's not always as literal as someone using model lines to represent a table, but sometimes it's people just dumping in a family from online without checking any of the data or the parameters and wondering why it doesn't schedule properly. That's a really common issue I find. as well as this just not modeling carefully. So missing little details. For example, if I'm doing a takeoff of the face area of all the walls in a project, which we almost never do because it's so much work, you have to do things like trim around the beams using edited profiles or something like that. And it's a lot of work, obviously, but if you're going to go for a proper full takeoff, you do need to think about these little details, and they're typically not going to be in plan. Usually they're going to be in 3D or section or some of those harder views to work in. So it does require a more holistic approach to actually rationalizing your BIM model. I have actually worked on projects in the past where we had to model to this detail to deliver on the goals of the project, to have clash-free modeling, and there was all sorts of reasons for it. But also the cost takeoff strategy did rely on the walls being accurately modeled, which was quite complex. As well as this, just having consistency in how your data is set up is crucial. Anyone that's ever tried to create a Revit schedule in a really big model, you probably know that if a parameter exists in a family somewhere of that category, you have access to that in the list of available fields. And so you'll just get bombarded by this massive amount of data fields that you can pick from. And often they can be parameters that almost have the same name, or maybe they do have the same name, but they have different GUIDs. So it can be pretty intense if you don't have a data structure set up. So you can see here, like I just generated like 6 different width parameters just by mucking around with some project and shared parameters, and just add a lot of redundancy to the model without trying too hard. So you just have to be careful that if you do want to commit to something like this, you do need that data structure established. As well as this, making things the right category is also really important. I find sometimes people don't really have a strategy for what category a family should be in Revit. And I think a company should always have their own principle, you know, of what's a TV belong to? Is it electrical equipment? Is it specialty equipment? It's obviously not casework. Like there's sort of those sort of decisions you need to make pretty early into the game when you're building a content library. Otherwise you may as well just start, you know, turning your shoes into telephones and talking to people in your shoes. So I think like I've got a system I use that I sort of teach other people, which probably is pretty close to what other people do. I've sort of listed it here, and feel free to screenshot it if you want. It's pretty generic. I try to avoid using too many categories. A lot of the other ones I sort of reserve for MEP. So I try not to use like electrical fixtures and electrical equipment. I try to reserve those for actual MEP models. That way there's better graphic control when you work with an MEP based model. One point I do want to make though, is I try not to use generic models too much. I find that this category gets really heavily abused by people that don't want to spend time thinking about what category something needs to be. So like my generic model folder literally has about probably like 20 families in it, and then the rest are all like assemblies and room families. But some other companies I've worked at, the generic model folder becomes an absolute mess. So I do try to avoid this category because ultimately what is a generic model? It doesn't relate to anything in the real world. It's just a generic object that we can't be bothered categorizing or that we can't categorize. So I usually put really generic things in here, like conveying systems, like escalators. You know, maybe they're site, maybe they're not. And sometimes the good thing about generic models is that they cut. So sometimes that's one reason people like to use them, but I do try to avoid using them otherwise. But ultimately having a strategy is the point. So I think it's not really Autodesk or the Revit developer's job to give us the cost takeoff system. We have to design it and make the strategy work ourselves. This is obviously a perception that the industry has been exhibiting lately with the open letter saying that, you know, we think the software should be doing more for us. And if you put the time in, you can actually get a lot of really good results out of Revit, as a lot of us probably know, given we're all quite passionate about it. So we're just going to jump into some of the takeoff strategies, and I'm just going to show them in a live demonstration. So hopefully everything works out. Bit of a risk, but I'm just going to start by talking about what I call unit cost by count. It's the most basic takeoff strategy. I'm just going to sort of rearrange my screen a little bit. So just give me a sec. I've got a little script to keep me on track. I'm just going to jump over to Revit. And I'm just going to work first of all with this model here. So I'll just have to go to the main one. Actually, I think I'm going to go to my basic house project. So this is actually a model I'm working on for my course platform, but it's just a basic residential housing project. It's fairly clean, like everything's set up to be documented as well. But I guess the reason why I'm using this model is because the data is quite clean. The families are quite organized and the parameters are pretty heavily structured. So if I go to, say, all my specialty equipment, you can see that everything is quite uniform and arranged. Now, I know in reality, models typically aren't this clean. We don't have time to, maintain our systems as heavily as, say, one guy in Australia working in his home can do. But I guess if you do get the time, it is worth trying to establish a cleaner system that you can roll out on your projects. But I guess I'm just going to start with obviously the most basic takeoff you can do. Let's say in this case, I just want to get all of my plumbing fixtures. I think most of us know that we just go to schedules and quantities, go down to our category and create a new schedule. Usually you want to pick the right phase as well. Now at this point, you can see that I've pretty carefully mapped all my data so that it's all stacked and located in one place. Otherwise, you might find some pretty wacky parameters elsewhere. There's a couple, like say the IFC export as and export type parameters that have to be named that way just because of the way it's set up. But in this case, all I'm going to do is use my common code handle. I'm also going to get my description, which is a shared parameter in my case, that's also pushed into the description field. It's like a double up parameter. And a really important field, if anyone's not aware of it, is count. Count is like a default parameter that comes with most schedules that essentially does a tally for you. And this is pretty much the backbone to generating a quantity takeoff. I'm just going to make the schedule at this point, just to show you what I get. So at this point, we get an itemized schedule. So every row represents an item. So at the moment, everything's just one of something. So it's not a very useful quantity takeoff at this point. Typically, you may want to filter as well, but in this case, my system is quite clean, so I don't need to filter. But I'll do some filtering later on. But in this case, I'm going to sort by code, which is basically telling Revit, I want to order my schedule by code at this point. That's not that helpful. But if I tick off this box, itemize every instance, this is the key. And this will actually say, I want to sort and then group essentially by that same field. And now they all get clumped together. So we can see now that I've got like 2 showers, 6 sinks, 1 tap, it's all getting clumped together, and count by default is a special parameter in that it knows how to total itself without you having to tell it to form a total. But there are other parameters that work a little bit differently. So let's add cost. So I'm just going to add the default system parameter for cost. At the moment, nothing has a cost. So what I'm just going to do is I'm going to put in like a couple of numbers and just muck around with it. Now, obviously, these aren't very realistic prices, but that's all right. I'm only going to populate one schedule. I probably should have built a Dynamo script to just do this with random numbers, but that's all right. Just bear with me. You get the gist. Actually, I won't do the last few. But at this point, we have cost, but you might think we're looking at total cost there. So like, 6 sinks cost $50, but in fact, we've just told each of those sinks they cost $50. So at the moment, this is sort of like what I would call like a unit cost. There are 2 ways you can do a total cost at this point. One of them is to go to formatting and tell the cost field to calculate totals. Now, sometimes I use that, sometimes I don't. The reason I don't do that sometimes is because I like to see my unit cost, but also my total cost. So it tells the user like the logic of how the calculation is formed. And in this case, we can use what's called a calculated parameter. It's this button here. There's actually a lot of really good sort of controls around here. If you don't pay attention to them, you sort of miss out on them. Another one I want to point out while I'm here is combine parameters. This is a really handy tool. If anyone's not aware of it, you essentially just can concatenate fields together. So if you have like a code that's made out of multiple bits and pieces, like an ISO 19650 sheet number, this is the way to do it. So definitely keep your eye on this tab as well. Whoops, don't want to go to help. Anyway. So what I'm going to do is add a calculator parameter. If anyone hasn't seen this before, you essentially just add the name of your parameter. Now, we're not adding a project parameter or a shared parameter. This is just a schedule that belongs. This is a parameter that belongs to the schedule. We're going to make it a currency parameter. So data type is critical, as tends to be the case with most things in Revit. And we're just going to go formula. Now, if you know the name of your parameters, you can just type them out. But what you can do also is just call on this little list of things. And in this case, I'm just going to say cost. Actually, I think, whoops. I think in this case, should be like count. Oh no, how did I do this before? Actually, I've done this a different way before. I knew I'd trip myself up on a live demo. There is a method to using the field here. I think in this case, I had to use a shared parameter instead. But that was, yeah, I've used a different model to the one I was using before, so I'm going to trip myself up here. Yeah, actually, I'll probably skip this and I'll do a video recap on my channel for that. Sorry. I knew I'd get myself once at least. But yeah, count's a special parameter. they can't be used in tallies, unfortunately. So in that case, you'd have to use a different method there. But what you could do is build a shared parameter that just counts as one for every family, and that would be enough. But in this case, what I'm going to do instead is I'm going to do a multi-category schedule, because a lot of people don't understand sort of exactly what a multi-category schedule does. So in this case, a multi-category schedule, it sounds like it brings everything together in the entire model, but it's not quite the case. So in this case, I'm just going to add my code field and my comment field. And I'll just add count as well. As you can see, you get a lot more parameters when you do a multi-category schedule, because essentially Revit is like scraping a lot of different categories. So you can see I'm getting things like my door parameters and my window parameters. So it's starting to pick up a lot more elements. You could filter in this case as well. I'll do some filtering after. I'll just sort by code, and I'm going to turn off that itemized parameter again, so that we're just going straight into rows by code. And at that point, we probably don't really need to change anything. Now, you get a few things, like you'll get things that don't have codes. These typically are things that aren't intended to report. There are various ways of managing these out. I find depending on the schedule that you're working in, the method is different. Sometimes one method that does work is just to say code has a value. I know sometimes this works. Yeah, so in that case, it works. Some schedules work differently, where if it's a number parameter instead of a text parameter, you can say parameter is greater than 0, and if it doesn't exist, it'll take it out as well. I find that sometimes works. But the reason why I wanted to make this is because it's important to note that we're not seeing every single category in the model. I believe it only shows loadable categories. So you don't see like walls and roofs and ceilings. So it's not like as useful as it could be. It'd be great to have a schedule that picks up like every single category in the entire Revit model. You could do some pretty crazy things if that was possible. But things like the walls don't appear. So you do still need to work a little bit between multi-category and category-based schedules, I find. I do use category-based schedules for things like all the fixtures in the project, because typically these are all loadable families. So in this model, for example, I think on page 3 of my schedules, I have like a combined fixtures legend, and that crosses categories like plumbing fixtures, specialty equipment. I do a bit of filtering in this one. So I actually separate all my joinery, which is casework. I think in this case, I just say, does the code begin with F dot, which sort of reinforces that if you do have a really universal coding convention, it can save you a lot of time when it comes to filtering. If you know exactly what something needs to start with or exactly what you want to filter out, you can save yourself heaps of time. And I find that some companies, they don't have like a rigid enough coding structure that they can easily just manage this stuff out. And it becomes even more relevant when you get to Dynamo, where you really need to predict your data structure to run scripts across various models. For example, that first presentation we saw, which is a brilliant system, it obviously relies on things having particular names or systems or syntaxes in order for Dynamo to detect certain objects out of the entire Revit model. And the same goes for quantifying elements as well. But at this point, we've pretty much looked at like the basic fundamentals of just counting elements in Revit. I find some people don't know this, but most people have a pretty good grasp on it. And the other thing I just want to point out here that a lot of people miss is like phase is relevant inside of schedules. So you have a phase filter, just like you do in a view, and you also have the phase that you're currently on. So you do need to be really careful if you're on a phased project with stages of work or a demolition phase, that you do match your phase to the intended phase where you want to count all your elements. I find sometimes people will miss this and they might do a existing phase by accident, and you end up saying, oh, we've got no equipment, okay, and then it turns out there was a whole phase of office fit out that you missed on like a later refurb phase, for example. So that's really important as well. But I guess I'll move on to like the next category of quantification, which is a rate cost by data. And I want to sort of show an interesting little quirk that the structural framing category has, for example, because some families are harder to predict the cost and reporting behavior of. And structural framing is a really good example of when you have to be careful in interpreting what Revit tells you when you're trying to measure something. So I'll just jump into probably just like a new project and just show you how beams actually behave. And I'm sure some people have probably seen this before. I'll just use my default template. And all I'm going to do is just model like a structural beam. I think I've got a UB in here. I might just load a UB actually from my library. bear with me. This is one good thing about being a consultant. You get to set your library up exactly how you want it to be. So everything's exactly where I want it to be. Right, so I'm just gonna make one beam. So I guess at the moment, we're reporting the length of our beam is 15.8. I'll make it 10 meters just to keep things easy. And I guess we can see down here, our length is reporting as 10 as well. There are various ways of changing a beam's length. One is to just drag its end. The other one is to play with the start and end offsets or copings. So in this case, notice that Revit still thinks the beam is 10 meters long. So I guess in a physical sense, this beam isn't technically that long. It's been taken back to maybe form a connection with a column or some sort of junction, for example. I can see in this case, I actually have a parameter built into my beams called reporting length. And this actually reports back on the physical end, start end offset length of the beam. I might just show you how I set that up from scratch, just so you can sort of see the trick. Because in this case, obviously, the family is not quite behaving how we would expect it to behave predictably. So in this case, I might just open up one of the Autodesk beams because they don't have this system implemented. And again, I'm not a structural engineer, so like maybe there's good reason why it works this way. But I guess there's no harm in introducing an additional sort of way of measuring the element. I guess as an architect, I think more about the physical aspect of the element, but maybe there's different reasons from an analytical modeling perspective to why it works this way. So I guess you can see length is associated to these two end reference planes of a beam by default. But these are the true ends when you do the start end offset. So it's a very particular way that the family is set up. In this case, you can just set up a dimension and associate a parameter to it. In this case, I'm just going to use a shared parameter. Just from my shared parameter file. I've got a special reporting length, and I'm just going to make it a reporting instance parameter. This way the family drives the parameter rather than the parameter driving the family. And as a result, we'll now get two different metrics when we adjust the length of our beam. And there's a few reasons why I do this. I guess I'll show you a couple of them. But if I create like a beam there and muck around with its length now with the start end offset, we can see that if we go down to the report length, we're getting the true and correct physical representation of the beam. So if you wanted to cost the physical aspect of this beam, you would need to intervene with the way that the data reports by default. Another reason why this might be useful is if you're, say, a structural engineer and you want to do really quick cost takeoff and you know exactly what cost rate this beam has applied to that particular profile type. Well, in this case, you'd want to just embed it in the family probably. You wouldn't want to have to keep going out to Excel and multiplying it with some sort of lookup table. It's much better to find a way to build it in. Now, I don't always build costs into families because I don't think that it's always the best place to store cost data because costs obviously change and they vary depending on which contractors supplying the objects that you're dealing with. But if you do have a very generic sort of costing strategy, it's pretty safe. So in this case, one good thing about introducing a reporting parameter is it means we can also use it in any formula at this point. Whereas some parameters like length, when they're system parameters, they do get a little bit sensitive when you try to introduce them into other formulas. Now we need a few things at this point. We need a cost rate, and then we need the actual cost. So at this point, the length of the beam is an instance parameter. So we're not going to be able to use the cost parameter because the cost parameter is a type parameter, and you can't drive an instance-based condition to a type parameter. So this is one of the limitations of the cost parameter in that it's just locked in as a built-in type parameter. So at this point, you do need shared parameters, unfortunately. So at that point, you would need to just add a couple. So I'm just going to add a cost parameter, so my own proprietary cost parameter. And you could make it type-based or instance-based. In this case, I could probably just make it, actually this one is instance-based, but for the rate, you could make that type-based because typically different profiles of a beam would cost different amounts of money per linear meter. That's, I think, how most of them cost their beams. So I have a cost rate parameter I use as well. And this one could be type-based. So let's say it's $50 per linear meter. I'm not quite sure exactly how much it would cost. And in this case, we would be able to use this parameter as a formula. So we could say the cost is equal to this times my cost rate parameter. That's the only problem with a really clunky naming convention. You have to end up, you have to type things manually. At this point, I've hit a pretty important thing here. So what I'm doing is I'm multiplying a length parameter times a currency parameter. to form a currency. So the problem is that I have to manage my units out because I've got a length times a currency. So I need to manage that length out. And in this case, I'm dealing with meters. So I can just divide by 1 meter. So I type in 1m. And Revit knows to manage that out now. It's sort of like doing division with X and Y variables. If anyone's done it in maths, it's the same principle. So that's pretty important as well. I know that trips a lot of people up when they're dealing with units like currency. And at that point now, we would have a beam that is always going to be able to report its cost in some form. So now we should have a parameter down here in this proprietary cost parameter. And you can see as my beam changes now, so does my cost. So this is live, and the engineer could easily just quickly check the cost of their beams. You know, we could model a few separate beams and just go and form a little structural framing schedule. So I've got a lot to cover, so I'm just zooming around a little bit. And because I've added this cost parameter to my structural framing, it's now available as a parameter that I can put into the structural framing schedule as well. Even if all the beams in the project don't have this parameter, you can still put it in the schedule. It's just that the ones that don't have the parameter, they won't show any values. But at this point, you could just say, what is the cost? And you could pick whatever parameters you want. Like I have a couple of coding parameters to sort my beams. Now this was an Autodesk beam, so obviously it doesn't have all that data. In this case, you might need to use something like family and type. It's probably the only really generic parameter that works for Autodesk families. But I guess now you can see my beam doesn't report with it as well. So there's a few sort of trips and hurdles you have to deal with. Now you can also work with 2 cost parameters at the same time and just total their values. So if you want to add cost and cost 1, like my shared parameter, what you could do is you could just add like a calc cost parameter and calculate the sum of those 2. So I could make a currency parameter, and I believe it should let me do it this time. I'll have to return to that count issue. And I'll just plus those 2 together. And at the moment, I believe because they don't have an actual cost, it probably won't support a sum. I think until they have a value, yeah, there we go. So they do need a value to support a sum function. And then if you wanted to just show that total cost and just hide the rest, if you go to formatting, we can just hide those fields. And now we just see this field instead. So that's pretty important. And probably, I think I'll save something for the next one too. I just remembered another thing I wanted to talk about. I know I'm probably bombarding everyone with information here. So a couple of families I wanted to show as well that are quite crucial to what I've been talking about. One of them is a bench that I've been building, and this one I use on a few projects with clients. It looks like a pretty ordinary bench, but if you open up the parameters, the bench is built to calculate its own area as it changes. So it's a U-shaped bench and it's flexible in all directions. So what I do is I build a formula for each piece of the bench essentially. Each side of the bench can also be extended by a certain distance because it's like a kitchen overhang bench as well. So it's pretty wacky. I think that one, I took the extension behavior out, and essentially it just means that as I work in the model, I can see the total square meterage of the bench because some families by default don't report all the metrics you'd want them to. For example, casework doesn't know how to deal with like a top surface face. Alternatively, you could look at things like Dynamo to analyze the geometry of the element and find all the top facing surfaces. But I do prefer to try and build in behavior into families where possible. This way you can just immediately add this to a schedule and really easily call on it to do like say a square meterage rate to a stone benchtop material. And I try to usually use all the same parameters. So if I use an area parameter in my content, it's always the same area parameter. It's not like a casework area, furniture area, because this way you can work cross-category in multi-category schedules. And you could really unlock some interesting ways of sort of mixing and matching data in like, say, mass takeoff schedules with casework mixed with furniture, for example. So I do find that if you can sort of plan that data structure out as early as possible, you really do unlock some pretty interesting opportunities. I think I had another family that had some inbuilt costing. I think this one is a window that has a nested architrave plus sill internally. So this is the outside sill, this is the inside face. And this is a nested shared component. So it gets carried through to the project as its own family that can be scheduled individually. And what I've built into it is I've built some formulas that determine if the architrave is on, it reports a length. And if the reveal is on, it reports another length as well. This way you can actually schedule your total linear meterage of architraves on the windows in a project. This is really important for, say, like residential scale projects where you do need to really quickly be able to sprout off figures and check them against subcontractor rates and quotes. So sometimes if you can build like little components like this that sort of individually control themselves across multiple families, I find that this makes it easier to sort of maintain a cost takeoff strategy. Obviously, this is a very detailed little element, but I do find that sometimes the devil's in the details when it comes to cost. So I think that was all for that section. Probably a lot of stuff I bombarded you with there. But this part's a little bit easier. It's what I would call rate cost by inherent data. So we just dealt with adding parameters and manipulating data ourselves, but there's already a lot of data in some categories of elements that we can take advantage of. For example, floors are a really good category for just doing takeoff because they already report their area and they report their level. There's a lot of ways we can deal with them. It just becomes more about knowing where to embed your cost data to get the most out of it. So I'm going to go to my advanced project. So it's the residential project, was pretty small. So this is like the interior component of my advanced sample project I'm developing for my course platform. It's not only like a big model, it's also full of documentation. So I feel like there weren't really many good references for like BIM documentation available. So I'm going to actually release this as like a fully documented project with, proper wet area drawings and stair drawings and the lot. You have to excuse my blue dimensions. Anyway, so the reason why I'm using this model is because I've went to the effort of doing something I'd probably never do in a real project when you don't have time, but modeling every single finish as a floor, which is, pretty exhaustive. But obviously it makes it perfect for doing proper cost takeoff for the floors. There is an alternative strategy to this that I'll touch on as well, which is just using the room instead of the floor and embedding the floor data there instead. But if I make a floor schedule, in this case, I'll just get my code and my comment, but we have the area parameter by default, which isn't something that we set up or control. It's just built into the program. So it's perfect for this. At the moment, I don't believe I have any cost data in this model because I don't want someone to go and generate a figure from it and then blame my company. I hope people wouldn't get that silly, but you never know. So at the moment, obviously everything's a row item. So we do need to re-itemize this schedule by code. And we'll turn off that itemize box. Now it's all clumped together. In this case, we can see that the tile is sort of, there's something going on with the tile. So the reason why this is happening is because the way that I manage my system families in Revit is I give them a class, which is their code, and then I give them a system, which is their variation on the class. So I have a tile 1 and a tile 2. So the way that itemize works is you can also introduce extra layers of itemization. So I can say clump my data by code and then clump it by system as well. And once it's clumped it by code, then it will re-clump it by system. I might just zoom in so you can sort of see it a bit more easily. And now we can see that we've successfully sort of broken apart those two types of tiles. Now at this point, some things are happening. For example, I can see an area on tile 2, but not on the rest of them. Now the reason I'm saying this is because tile 2, there's only one instance of it in the entire project over here. So it's reporting itself as an itemized row of one item. What I do need to do is actually calculate totals on area, and this will clump together total area. So now I can see all my square meterage. At the moment, there's no cost, so I'll just chuck in like a cost rate. And it's important to determine how you're costing your elements. Like, is it by square meter? Is it by something else? Floors are like a really easy example, but a really complicated one is walls, for example. Is it by linear meter? Is it by surface face area? I know most QSs do it by like actual measuring it off the drawing at linear meter, and then they go to the wall details and say, oh, this wall on average is going to be 2.7 meters high. So you do have to think about that with some categories of elements. It just depends on, I guess, your own strategy. So we've got rates now. Again, this is the rate cost, not the total cost. I believe in this case, I could just, do the calculate totals in this case. But again, in this case, I should now be able to do what I was trying to do before with the count, which didn't work, which is to do a calculated cost. I think in this case, it should support it. I believe area can be used in a calculated field. So I'll just call this total cost. And in this case, we're going to have to manage some units, which is why I wanted to show it. So we're going to be multiplying area by cost. And if you remember what happened with the beam last time, we don't get a unit that works. So we actually need to divide it by 1 meter. And we actually need to divide it by 1 meter again, because we're managing out a squared unit in this case. And now we'll get a total cost field. Again, we get a calculation on this one because there's only one of them. But then after that, we'll also just do the calculate totals. And now we have a full priced takeoff. We could also get more creative, and we could also break it up by level. So we could introduce the field of level. And I'm just going to make it a hidden field because I'm going to turn this into a header. Now, this always seems to trip people up in Revit, how the header mixes with the itemization function. You put your headers first typically. So if I want to make my header level, I'm going to make it a header. For now, I'm just going to put a blank line between each section, broken up by level. Then you can do your itemization fields. So code and system. And now we can see we get them all broken up by level as well, all broken down with subtotals. So we can start to see we're getting some more meaningful takeoff at this point. You could also add a grand total to the count. So we could do count and totals or just totals. In this case, I'm just going to do totals because we're not really counting anything. And now we get the total. And we could also go to our header and introduce a footer as well. And this will do subtotals for each section. So now you can start to see that you can get like a much more itemized and broken down cost takeoff. And I find that that step usually is where most people get confused, just the headers mixed with the itemization. Once you do it for a while, it becomes really easy. Like I'm sure a lot of people here are looking at this going, oh, it's a piece of cake, I've done this before. But I do remember when I was learning it and going, I have no idea how this works, and just mixing and matching those headers and just getting really frustrated. I wanted to show a really devious thing that Revit does as well, that I have seen become a problem on projects before. Let's take cost. I'm just going to take a few things out now. I'm going to take out level, take out total cost. So it's just gone. And we're just going to look at our original schedule. We're going to, in this case, I believe, yeah, so we've got 60 here. I forget exactly what I was trying to do. I think what I was doing is if we don't calculate totals on our area, we can get some funny things going on. So if we just don't calculate totals on area, and if I copy one of my floors exactly as it is, no changes, and we go back to our, where's my schedule? Let's go find this thing now. So it still tells us we have 29 square meters of the floor, which is a bit confusing, and you might make a bit of a snap judgment and go, okay, I've got 29 square meters, but because we're not calculating total, what Revit's really telling us is I have 2 floors and the area is both 29 square meters. So that can be a really devious little mistake people can make, especially in a schedule where you're just dealing with like a counted element, not a finitely measured element like a floor. So you have to be really careful on that one. I think it's just always safer to do calculate totals. That's nearly always the right choice in most scenarios, I would say. And then you do get the true and correct tally of area. And yeah, just something to be aware of. So I think I was just gonna look at walls as well. So I'm just gonna go to a new project with walls. I'll just make a new project. And I was just gonna have a look at the way that walls report when they join, because I think that's a really interesting behavior to show, because people don't necessarily always understand that fine behavior of how things work. So I'm just gonna do a meter, and I'm just gonna make it a meter high, so that we can really easily predict what the area should be. So I'm just gonna do unconnected height of a meter. I'm just gonna pick a brick cavity wall from my template. So it's got a few layers and it's a bit more interesting. Where's my brick cavity wall? There it is. Okay, I'll just do a section box as well. I'll do a section box later. Anyway, I'm just gonna go to a floor plan so I can have a look at this wall. Obviously it's just one wall, it's not very exciting. But at this point we have a meter by a meter, so the area logically is a meter squared. If we take another wall and model this at a meter, so maybe I'll make my finished face exterior. It's important to note, I'm seeing a bug in Revit here. I don't know if anyone's realized this before, but if you have a wall that's below, I think it's below 1100 or a meter, it shows as projected, even if you go low enough to cut through it. Really strange bug, and I think it's always been there. I think that happens to me in my actual video from YouTube, and I get really confused and have no idea what's going on. And then I learned that after. So now we have 2 walls. So in this case, we can see that their length and their area is different. So the length is the same, it's 877.5, but the areas are different. So something's happening here. And I know a few people get sort of tripped up on this and not realize, what's happening. But in this case, I guess we can sort of figure out why the length is reporting the way it is. So in this case, one of the walls is sort of getting precedence to the other one. So in this case, you can see, I think in this case, we're going to the center of the join. That's what's determining that 877.5. But in this case, we're actually seeing like a bit of hierarchy on this join. So I might actually just make these 2 meters tall so we can see the wall layering. But the way that walls join actually influences how they're costed as well. So in this case, if I go to the next condition, obviously I can flip that relationship. And now I'm getting a full report on this wall and a partial report on this one. And this sort of does work for some types of walls. Like for bricks, it actually makes sense because the brick would typically go out to a corner and then coin to the next layer. So it's okay to measure it that way in most cases. But sometimes if you're doing things like partitions, it can lead to some little minor discrepancies in how you get the total. So there is like that need to sort of work with a known margin of error or discrepancy when you do like a mass takeoff for a really generically modeled system. So that is something to be aware of. And also that can determine like the assumptions that you make about what you're measuring. You can sort of abuse and get around it by using some pretty weird junctions like miter. So I could just miter this wall, and I believe if I do that, I think they both then think they're 2 square meters. Yeah, so you can sort of trick it into doing different sorts of things, but it's sort of like, it's behind the scenes, and if you don't know what you're doing with it, it can be quite dangerous. So you do need to sort of just learn more about the systems and how they're reporting their data to you before you really start getting into like, those hand-on-heart takeoffs saying, I know that we've got how many square meters of wall on this entire project. Otherwise, you might get really deep, and then the QS goes and uses a different software, and it's just actually like you've underreported like by 100 square meters. So you have to be careful with that, especially with walls. I find walls are probably one of the less reliable elements for takeoff, just because usually you're trying to deal with different layers of the wall that occur at different positions from the face of the wall. But we will look at one more type of method, I guess, to analyze how we can sort of work around that. In this case, we're going to be looking at, I guess, a material takeoff. Before I do that, I did mention before that instead of doing things like measuring all the floors in the project, you can use the rooms instead. I know a lot of companies do this, and there's nothing wrong with it. It's actually like a pretty reliable technique, I think, if you know what you're doing. But say on this residential project, like I've got all these rooms, and I'm not modeling like all the floors in the entire project. I'm just modeling the ones that I want to graphically show. So by default, I just, because it's a really small scale project, I do a few little Revit hacks, like I paint the concrete with carpet just to not have to model all the carpet in the project, but in Enscape, then I can still see carpet. But what I do instead is I embed a field inside the finish. In this case, I have a finish scheme, which is tied to a key schedule, which will sort of be part of my Revit hack that I talk about later, because I think this is a really handy technique. But it's essentially telling the room what its floor finish is. And then instead of scheduling the floors, I just schedule the rooms. So I think it's in schedules 2, no, schedules 3. So whilst it looks like I have a floor finisher schedule, what I really have is a room schedule, just made to look like it's a floor schedule. So it's really actually just reporting on the room's floor finish and its area. So sometimes you can be a little bit more creative when you're doing takeoffs, especially the really high level, doesn't have to be 100% accurate takeoffs. Obviously, if you're committed to like a level of cost tolerance, like probably not worth playing with things like this at that point. But if you're just working for, say, like a residential builder that just wants to know roughly, is my subby, on the right margin, this is a really quick and easy way to do it. So yeah, definitely worth thinking about those alternative ways of measuring takeoff. I think I'm almost done. I probably almost went over my time, haven't I? So the final thing I'll just touch on briefly is material takeoff. This is like the hardest system to use for takeoff. It requires like a super robust system of codes and materials. And I find that even I don't have enough time to make the system work. It's sort of like a tool that I've played with, but have never actually successfully holistically rolled out on a project. So even if we just go back to this really basic project with 2 walls, because that's how complex a material takeoff is, like you almost have to go down to just a couple of elements to understand it. If we go to schedules, there's actually this type of takeoff here under schedules. Some people probably haven't even used it before. Again, it's not a very useful thing if you don't know how to use it. So in this case, you can do multi-category or you can do single category. Again, you're going to run into the same limitations as schedules. So you're not going to be able to schedule walls next to doors, for example. Multi-category won't pick it up. So in this case, we do have to use a wall schedule. So material takeoff schedules are a little bit different in that you have the parameters of the wall, but you also have the parameters of the materials in the wall. And this isn't just like the structural material, this is every material in the entire wall. So you do have to be careful not to mix around with like cost parameters and material cost parameters. Typically with a material takeoff, you should really probably just be focusing on the material. So in this case, I'm just going to get the materials cost and the materials area. And I'll probably just also get the description so I know what the material actually is. I might actually need to use the name actually. And I'll also get the family and type so I can just see where the material is coming from. And what we should get is every single layer inside those walls. So just for 2 walls alone, we already have eight materials we're measuring. And whilst it looks like everything is 2 square meters, you do need to be careful sometimes with unit formatting to make sure that you don't make it too rounded off. So if I go to field format and I go to 2 decimal places, they're not the same. So depending on how far back through the wall each of those layers is, it's going to be a different takeoff because it's being measured to the end of its terminating point at the next wall. And again, the joining precedence on the walls will also influence the layers of all these walls as well in a material takeoff. So it only gets more complicated the more deep you go into the wall and how all the layers join together. But in this case, we can do like a really heavy takeoff of all the materials in the project. Now, I usually don't use this just because it's too hard to accurately model everything in the entire project and not have the material takeoff be affected in negative ways, because there are a lot of ways you can really mess with a material takeoff. One of my favorite ones to show people is just to do something really stupid like paint a brick wall with brick and just show what sort of happens to the takeoff. So I'm going to go find my brick material and I'm just going to paint my brick. Now you might think in a material takeoff, well, that's fine because it's already brick, so it's just going to be brick. But what you get instead is you get the brick and you also get the painted brick reporting twice. So you can get some pretty silly things if you're not careful. There is actually a parameter called, I think it's called is paint. It's under material as paint. And this can sort of help you audit. I think in this case, maybe I didn't paint that properly. Might not have. It should show up. Interesting. That's weird. Usually it does show up. Live demos. I'll just paint it with something that's not brick, but I do seem to recall that the brick was the culprit. Maybe if you paint it on the surface that isn't brick, but still is in the same system. Yeah, so now it shows up. Okay, so you can't paint the exact same surface with the same thing, but you can paint another face, and you can see we haven't lost that reporting layer of the plasterboard. Now we've got brick on plasterboard, so it doesn't really lend itself to a material takeoff very well. Now you can filter out all those painted materials just by saying, is as paint equals to no, and that will get rid of all the paint. One good thing about this system that people probably aren't aware of is you can just say as paint equals to yes, and then I can just click on this row, go to 3D, and it tells me where the painted material comes from. So that can be pretty handy. You can also put those all into a single itemized row, and then that will just give you every single element in the entire project that has paint on it. Now there are ways to do that in Dynamo, but that's a really nice little shortcut in the model. Like usually I actually build a schedule in my project for material takeoff just to find painted materials by category. But you can sort of see that material takeoff is pretty complex. And I think unless like everything is set up perfectly with the right codes or the right materials, it's probably more time than it's worth. Because on top of that, you also need to manage your materials. So you actually need to populate the cost data in your material itself. And as well as this is quite limited. You can't populate shared parameters into material definitions. So it's pretty limited what you can do with this. It's a little bit like keynotes where the system is sort of locked in and you can't really play with it too much. But I'm sure there's definitely ways to use this, like at least partially, by focusing on really small portions of the model from a takeoff perspective. I have used it before to do things like acoustic panels in projects and say how many square meters of acoustic panel do we have. And that's probably the last trick I wanted to show you, in that if you do have a family, I might just go and grab that bench again that I opened before. I might just open it fresh. All right, there it is.
Just to let you know, it's overrunning slightly now. Is it okay to take some questions maybe?
Yeah, okay, no, let's go. I'll skip this one, but essentially you can paint a parameter onto surfaces to control the material like on a single surface. But yeah, I'll just power through the last 2 slides and yeah, then straight to questions. I'll skip this bit. I'll do a YouTube video on this, but essentially you can get all this data into Power BI and do a cost breakdown by category, and you can filter your entire model by element, and you can just get all sorts of metrics out of your model. But I'll skip that. There's a really good video by the Revit kid, if anyone watches his stuff, and he basically does the same thing. I sort of just copied his idea and had some fun with it. But yeah, if you're in doubt, check your model anyway. Don't work against the QS. Be their friend. And no more half measures. Yeah, all right, got that. So I know I covered a lot in that time, so sorry. Yeah, I'm sure there's a few questions. I'll just open up the thing so I can see. And thanks for keeping up, everyone.
I think there might be one from Mark asking. Yeah, I had a question on the walls, but you answered it already. Mark, is it possible to create a duplicate of the cost and then calculate totals for that calculated value?
Yeah. So you could add like a shared parameter on a project basis and then populate it there.
Could you not just do? Can you hear me? Hello, it's Mark.
Yep.
Hello. Could you not just create another parameter that's just equals the cost, and then calculate totals for that?
Yeah.
So
do you mean when I was struggling with the count section, or
when you're struggling with having both the calculate totals and when you add just the cost unit cost and the calculate the total cost as 2 columns? You just create another calculated value that equals cost and calculate totals for that.
That would replicate the cost data, but to conglomerate the 2 sections of cost together, I guess, was what I was doing, wasn't I? Or that?
I thought you were doing cost times count.
Cost times count. That was the issue where you can't use the native count parameter in a formula in a calculated field. I think in that case, I've only worked around that in the past by introducing a native count parameter to the families themselves. So that is just one. And that supports a counting mechanism. But yeah, I'm just trying to think.
I guess one thing you could do is maybe just create another parameter that equals the cost.
I get you now. Yeah, I get you. So you get the cost rate. Yeah, that works actually. That's maybe I have done that before. I'm trying to think. It's about.
We do it for like areas when we want to do area.
Yeah, no, that would work. Yeah, that's probably what I meant to cover. I just forgot it. But yeah, no, that would do it. So you just replicate the cost field, and then that supports its own totaling mechanism. Yeah.
Yeah. Cool.
Yeah.